In exercise 7-33, we're asked to determine the p-value here in part C, which is the part that a student is asking me about, given the test statistic equal to z of negative 1.15. So we decided, first and foremost, that we were going to do a two-tailed alternative hypothesis because of the fact that we didn't believe that it was necessarily going to be a mean bigger than 3.1 or a mean smaller than 3.1, just that we believed that the mean was different from 3.1. And so that makes it a two-tailed alternative. So basically we've got this kind of a scenario where they've made the claim that the average weight of the tuna is 3.1 pounds per year, or the average tuna consumption is 3.1 pounds per year. We don't know if our sample average will be above that, or if rather our sample average will be below at that. So what we basically have here is two tails, which is why we call it a two-tailed alternative. Now in our particular sample, we got a sample average that was 1.15 standard deviations below the claimed average of 3.1. It is below because z is negative, and obviously because our sample average was less. It was 2.9 pounds per year compared to the claimed average of 3.1 pounds per year. So we're going to need to enlist the help of our table of critical values for the normal distribution, since this is z, because we know the standard deviation of the population, sigma. And when we're looking up z-scores that are negative, this lower tail area is exactly what that table gives us. And so I'll load a picture of the negative z-score part of that table here on our next board. So here we see in the picture at the top of the table that it does display, this table does display the area that is below that respective z-score. So we're looking for a z of negative 1.15. So we have to go to the z column and look up negative 1.1, which clearly is right here. But because there is a 5 in the hundredths place, we have to go to the column with a 5 in the hundredths place. I think I referred to go to the column that has a z of negative 1.1, and I meant to say row. But now we're going to the column that has a 5 in the hundredths place, which is that column right in the middle. And if we follow this down to where we had a z of negative 1.1, we find that this is the area below that z. So let's picture this. What we have here is a claim that the mean amount of tuna consumed per year is 3.1 pounds, and we found that our sample mean was less than that. It was 2.9 pounds. And that sample mean had a z-score of negative 1.15, which meant that it was 1.15 standard deviations below the claimed mean. When we looked this z-score up in our table, it gave us the area in the lower tail, which we see here is 0.1251. But because we have chosen to do a two-tailed alternative, where we didn't say we thought it was less than 3.1 pounds per year, but rather that it was different, what we have to do is we have to take that area that we got in our tail and we have to double it, because both the area in that tail and in the area in the tail above, that is, has a z-score of positive 1.15, they both have an area of 0.1251. So we have to take that 0.1251 and double it because of the fact that it has two tails, each with that same area. And then that produces our p-value, and our p-value would in turn be 0.2502.